drawings, you will learn a lot. It's a very useful thing to do. And as I told you previously, you could create a program that makes the back button behave in a way different from what they described here. But then this will be a bad thing. Now, another remark about modes. So the person I learned this from is Jeff Raskin. And he is a superhero because he has formal training in mathematics, in music. He used to be an orchestra manager for a long time. And yeah, computer science as well. And he has the book which I read about this, from which I read about this, is called The Humane Interface. Unfortunately, he is not alive anymore, but his book will live forever. And if you read about it, he has a very clear way of explaining things. So he gives you examples of modes, why they are evil, and how you should reconsider your decisions in terms of visualization and user interaction to make your interface better. He has a son, and his name is Asa Raskin, and he also is somebody who works in the field of user interfaces. He has a blog where he writes about his experiments. I think you should have a look, just to get some input of a different type into your mind. What are your questions up to this point? Maybe you need some more examples or references?
My question is, how all these fit into the cybersecurity in order to be aware of, of the design?
We'll get to that. Some links are not obvious, and there are multiple steps you have to go through before you realize how any of these has an impact on security. I will offer a little more details about general HCI stuff, and then we can switch to security-related matters. All right, now. Another thing you have to keep in mind is that an interface should be forgiving. And when I say forgiving, I mean that if somebody makes a mistake, they must be able to undo it. And if something cannot be undone, then the person should be at least warned before they do this. But ideally, you should think about a way to add an undo feature. For example, have you used a program called GIMP?
Yeah.
It's a graphical editor.
Yeah, it's like Photoshop, something like.
Much better than Photoshop. Open source, cross-platform. And one of its coolest features, or one of its cool features, is that it has an unlimited undo stack. No matter how far you go, no matter what you do, you can always go back. That's a great example of a forgiving interface.
What's the name of it? GIMP?
GIMP, G-I-M-P.
I haven't used it.
You have
It's
to go
the-
back, man?
Excuse me?
No, it has an unlimited undo stack.
Yeah,
Meaning
GNU.
Whenever,
Oh,
how much
okay.
you can undo, you can keep going back.
Oh, okay.
Some people complain about the fact that it has a shallow learning curve. For example, it takes quite some time to learn how to draw a straight line with GIMP, for example. Some people say that. But I like it. Anyway, forgiving interfaces. Having an undo option is a good thing to have. Another example which I think is worth mentioning is how you take metaphors and embed them into your interface. One example that comes to mind is the process of saving a file. In the real world, let's say I sit at my desk, I take a document, and I begin writing on it. And then in a few moments, I change my mind and I go elsewhere and do something completely different. When I go back, my document stays here. It is in the exact same state as the state it was when I left it. I don't have to explicitly mark it as stay here. But that's not what we have with files in computer software. In computer software, if you begin working on a file, unfortunately, when you close the program, what most programs do is they ask you, do you want to save it, yes or no? What they should be doing is they should just save it, and when I reopen the program, it brings me back to the same state in which it was when I left. Hard drive space is very cheap. RAM is very cheap. I mean, it's not zero in terms of money, but it's much cheaper than it was many, many decades ago. Why is it so that people still ask me if I want to save my file? I've worked for hours on it. Is there some good reason for me to throw it away without saving it? So what happens is that these programs, they bombard us with message boxes. Do you want this? Do you want that? And that's what contributes to information overload. Whereas an elegant solution to the problem would be just save it, because as it happens in the real world, if I want to get rid of a document, I have to take it and I have to throw it into the trash bin. In other words, what we have in reality is that if you want to destroy data, you have to actively do something. If you don't do anything, it means I want to keep it the way it is. But that's not how computers work. Sadly, this whole idea with saving files has been applied decades ago, and now everybody else just keeps doing it because everybody else has been doing it for ages. But this doesn't mean that that's the way things ought to be on this planet. So that's what I say when I talk about forgiving interfaces. Another example is the format command or any other command which can cause irreversible data loss. Who has ever used the format command? To format a drive partition. So you type something like format C : then you press enter, and what does it say after that? It says all data will be lost, press Y to continue.
Sure?
Yeah.
Like that.
So I think that this specific use case is a perfect candidate for making it more complicated, because the distance between me and complete data loss is just one key press. If I press on Y, or in the case of some environments, you only need to press enter, and it will take some default action. What they should do is make you type some word, for example, confirmed, and then press enter. This way, imagine that I'm about to format a drive, but instead of formatting D, which I wanted, I wrote format E, which I didn't want. And while I was saying to myself, oh, what have I done? My cat jumped on the keyboard and pressed Y. Mm-hmm. That's not a good thing, but it could happen. Everybody who has a cat probably experienced this. Now, it would be much better if the program was designed in such a way that confirming such an important act as deleting data would require more than just one key press. This way you get to think twice before you do something, that's one. And second, you cannot do this by accident. So yeah, that's another example of why a forgiving interface is a good thing to have. Let's see. I had a longer list, and it could go on forever. Let me check if I told you about the things that I think are the most important ones. Oh, the phone is off. Not the computer. Yeah, just a few more key ideas. One of them is Hicks Law. Were you exposed to that?
No.
Okay, it's a very important concept. And it states the following. There's a mathematical formula that gets the message across, but I will give you the plain English version. And it goes like this. The effort needed to act upon an object is a function of the size of that object and the distance between you and the object. Now let me illustrate this graphically. Let's say I need to press a button and my mouse pointer is here. So what I need to do is I need to move it there and click. If this is a big button, clicking it is easier. If it's closer to me, then again clicking it is easier because the mechanical effort I need to invest into making this happen is small. In contrast, if you have a tiny button, and if it's very far away, then according to Hicks Law, this will be a difficult target. And the implications are that in this example, I have just one button surrounded by nothing. And it means that if you didn't get it right, just nothing happens. But what we typically have is we have other widgets around. And one of them could be, for example, let's say I want to copy files from one place to another. And one of the checkboxes could be delete original file. And I could accidentally click this instead of the thing I had in mind. That's why when you have small widgets, densely packed, from this perspective, you are making a mistake. Because this is a recipe for forcing people to make mistakes. The easier it is to make a mistake, the more likely it is that somebody will make that mistake. And that mistake can be a lost password, data loss, or many, many bad things can happen, generally. So that's Hicks Law. And there is another thing you should learn. And let's think about this together. I think it would be great if you could generate several very important conclusions in terms of Hicks Law. So given that we have a two-dimensional screen and a mouse pointer, which is controlled by a touchpad, track point, or a mouse, do you think there is some part of the screen that is very, very easy to access? Something that doesn't require you to have sniper precision to hit a little widget?
Ends of the screen?
Yeah. So we have several areas that are very, very cheap in terms of Hicks Law. So the edges and the corners. And here's why. If I want to move my mouse here, I just do this. It cannot go outside of the screen. I don't need to calculate exactly the distance I need to cover. I don't need to slow down when I get there, because the edge is the edge and the border is the border. So as an interface designer, you can take advantage of 1, 2, 3, 4 plus 4 more special places that are very, very easy to access. For example, in Windows 7, if you go to on the taskbar, by default it's at the bottom, and on the right side you have the system clock, but the rightmost element is a little area. If you hover the mouse on top of it, it shows the desktop. And that's a very cool feature. So what they did is they took advantage of Hicks Law. If you go to the internet and look for this, you will find some YouTube videos where people measure in concrete numerical terms the time it takes to interact with a widget, depending on size and position. And you will also see that the same thing works not only in interfaces, but also in the physical world. So there's a video where you have a little object. Well, you have a small object and you have a pen, and you have to hit this area with your pen or pencil. And as it gets smaller, the distance between them, then you can do this very fast. As it gets more distant, then the time is much longer, obviously. And you will also observe in the same video that the bigger the object, the easier it is to hit it, and the smaller it is, the more effort it takes. And not only that, but when it's... So here's what happens. Let's say I have to hit this area and it's this large. When I do this, it works that way. And if it's small, what they have empirically observed is that people often go beyond the area and then they go back. So a small object forces you to do more in terms of mechanical motion, and it also requires you to do more precise and more refined.
That's what has happened sometimes with the keyboard on the phones.
Yeah.
Mm-hmm.
And you try to type a word and then
And
it
then
will
the
go
other
to a different word or letter or whatever.
Yeah. So that's why you should really, really consider Hicks Law whenever you decide about the position or the size of a widget, especially.
There is a good example
Anywhere.
here too. The widget of
Plane.
selection of a plane. So they put an example that everything windshield, FM radio, ejector seat in the middle, and then cabin light. So
Yeah.
ejector seat should be in a separate place.
Because if you accidentally hit that one, you're ejected.
You're gonna.
It's completely, well, it's a crime against humanity to put something very, very critical along with something non-critical. Like in the case of a nuclear reactor, you could have an array of blinking lights. One of them says reactor is in a critical condition, and the other one is the tea is ready. It's easy to confuse them, so you should use more space, brighter colors for more important stuff. So that's Hicks Law. Another interesting law is Hicks Law.
I think this page is really good. It's I found another one. It says in the email interface they put archive, report span, and delete right next to each other.
Mm-hmm.
So if you want to archive, you can report it as a span or delete it by mistake because it's too close.
Yeah, even the Gmail, the one on the left, that is so clustered.
Mm-hmm.
The Gmail mail,
They
so
do that, but they are also forgiving. If you click delete or mark as spam, you have a little overlay window that says undo.
Undo, yeah.
And it's right there.
Mm-hmm.
So you see, even
So
sometimes you
should
have no
some
choice
other-
but to do this, but at least have the courtesy of giving people a way to get out of the problem which you created for them. Now Hicks Law is very simple. It says the amount of time it takes to make a decision is a function of the number of decisions, of options to choose from. Well, I could express it like this. Time how do you express the cardinality of a set?
It is.
Like a straight line?
Yeah.
Isn't this a modulus?
Yeah.
Okay.
Modulus.
Option count. So the more options you give, the more time it takes for me to decide which option is the one I want. So you should, so again, this is about information overload. And it has several implications. One of them is that it takes time, but everybody's in a hurry. Second, not every user is competent in making those choices. For example, has anyone ever used TrueCrypt?
Which?
TrueCrypt. It's a program for encrypting drives.
BitLocker.
When I used it some time ago, I remember that it starts a wizard, and then it asks me which algorithm I want to use and what's the key length. Now ask yourself the question, how many people know which algorithm is the best? And probably you will conclude that the answer is not that many. So what will people do to make a choice? They will choose the fancier name. For example, let's say I have, I just made it up, an algorithm called Acme, and there are several options. Acme 100, Acme 200, and of course the 500 deluxe version. What will be the most popular choice?
Deluxe.
Yeah, they will probably go for the deluxe version because 500 is 5 times better than 100. So if you know that your audience doesn't have the necessary background to make a decision, then don't make them make that decision. Just give them a very nice default value, because you are the author of the program, you know what's the best. Why lay the burden on people's shoulders? So that's Hicks Law. There probably is a fancy mathematical formula that expresses it, but in plain terms, just remember that the mental effort it takes to decide what you want is a function of how many options to choose from are available. And one last bit. There is a formal name for this. Okay, it is something related to information efficiency. So let's think about quantifying effort. Any operation you perform on a computer, like a laptop or a desktop, can be broken down into a sequence of primitive steps, such as click a button, a physical button, either on the keyboard or on the mouse, switch the hand between the mouse pointer controller and the keyboard, move the pointer from one place to another, and a mental effort. Now let me write these down. So one action is keying when you press a button on the keyboard. Another one is called homing, when you move the hand from one input device to the other. Another one is pointing. That is, when my hand is already on the mouse, then I have to move the pointer from here to here. So that's the process of pointing. And thinking. Because before I point to this or to that, I need to decide what's my target. What a bunch of researchers took a number of people and carefully measured the time it takes to perform each of these operations. And these times were
Sorry, what's homing again?
Yeah.
changing from keyboard to mouse and vice versa. Or in the case of this, it's from touchpad to keyboard.
Like shortcuts instead of going with the mouse into that?
No. So imagine that you're typing a text. You use both hands if you're a fast typist. And then at some point you need to do something with the mouse.
Yeah.
So what happens is that you take your hand off the keyboard, move it to the mouse,
Switch and use it.
do that, and then go back.
Go
So
back.
that's a homing operation.
Oh, okay.
So they measured very carefully all of these for different types of people.
And pointing?
Pointing is when,
Just go
Just
with
take
mouse?
and-
yeah, once
And go.
you're on the mouse, moving the pointer from one place to another. So they measured the times for these operations. I don't remember the exact figures, but I do know which ones were the most expensive ones. No, homing
Yeah.
was expensive because it requires mechanical effort. Pointing was pretty expensive too. Keying was cheap, and the mental effort was rather cheap as well. Now this brings you to another conclusion.
I'm sorry,
Yeah.
Alex. Keying was what?
Typing on Just the type.
Pressing.
Just typing.
Yeah. So as a fast typist, you can press keys very fast, and it takes you less than a second to do that. Whereas homing takes
Yeah.
above a second.
More effort. Yeah.
Now, think about this. You have a program that lets you perform a certain set of actions. A power user, a person who can type very fast, they can get things done without taking their hands off the keyboard. Because the keying operations are very cheap, it is reasonable for us to provide shortcuts and hotkeys for all the coolest and most typical actions. Some people, for example, disabled people, may need to use an on-screen keyboard which can only be acted upon with a mouse. So in that case, you have no choice but to add other ways of getting things done by clicking things on the screen. But it doesn't mean that that should be the only way things are possible. So you should always provide a method for people who can get things done just with the keyboard. In this example, VI is a nice tool. It completely eliminates homing and pointing because it's all keyboard based. So if we go back to the learning curve, if at some very, very distant point in time you get up here, then you will be able to get things done really, really fast. But before you get there, there's a huge time penalty.
Can you give an example of mental?
Yeah. So let's say I am uploading. No. All right. So I have a picture in my graphical editor, and I want to apply a special effect, like convert to gray, whiten, darken, whatever. So I have it on my screen, and now I need to press, let's say I have a dialog that looks like this. Choose a special effect, and there is a group of radio boxes. For example, this one, black and white, and something else. I need to press this and then confirm my action with OK. So that's the screen I see in front of me right now. I need to break this down into the following actions. So first of all, I need to think which option I want. That's a mental effort. Then, assuming that my hand is already on the mouse, I need to point to this option. For example, I want the black and white effect. So there is a mental effort, then there is a pointing operation, then there is keying. I have to click to indicate that this is what I want. Then there is another pointing act. I have to go to the OK button. And then there is another keying act, because I have to click on it. And you may also argue that there should be another mental operation here.
How is there a key in there? The end.
Clicking confirmation.
Click on the OK button.
That shouldn't be point. Oh, okay.
Well, keying is on the keyboard or on the mouse.
Okay.
Because once your hand is there, it's there. Now, imagine that this is X, Y, Z, and W in seconds. So what you do is you compute the sum of this, for example, 0.2 seconds plus 1.2 seconds, blah, 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 and in the end you get something like 5 seconds, for example. In other words, the cost of making this happen is 5 seconds. Do you think there is a way we could improve this interface? We could remove one of the steps.
Yeah. So
Confirmation.
you could reduce pointing like by just keying. If you just do a shortcut like with the keyboard or something like that.
Mm-hmm.
So that would reduce pointing and
Okay, what else could we do?
Just taking the OK off and just
Yeah,
clicking the
just when
button.
you click on it,
Yeah.
Mhm.
gets you.
All right, but you know that radio boxes are quite small. So in terms of Hicks Law,
yeah.
this is not the best thing you could have. But what you could have is something like this. Let's say a dialog that has 3 big buttons, and one of them is sepia, then black and white, and the other one. So if you choose the artifact, you just click on this, and the action is applied to the image right away. So there's no need to confirm. This way, we get rid of this one. We get rid of this one. And we only have one mental effort, because I only have to think once what I want, and then I just do it mechanically, relying on my muscle memory. So when you take this method and compare it to this method, in this case it took 5 seconds, in this other case it may take 3 seconds. And this is how you can save time and make things more simple. Another thing we just did here is we took into account Hicks Law by switching this to bigger widgets because they are easier targets. And let's say somebody chose a wrong type of effect accidentally. If we have a forgiving interface, we can easily undo the previous action. In other words, you must always keep into account all of these things and apply them in every possible context. Because you never know, well, you may not be aware of it, but all of these things are always there, influencing decisions such as this dialog versus this one. I'm not saying that this is the best. I wouldn't do this in my programs, but with this very simple calculation, I showed you that it's possible to have 2 different methods that give you the same result, but one of them takes less time and another one takes more, depending on what's your priority. If, for example, you design a system for a photo service, where you have people coming in and printing photographs from their SD cards. If you could design the interface in such a way that it takes less time, it would mean that in a 5-hour working day, I could process 100 customers and get $100. But my competing company that has a more complicated interface, in the same amount of time, they can process only 50 customers and only get $50 for that. So this is a correlation between the user friendliness of an interface and profit. Do you have any questions about this? Maybe we should analyze other examples. Oh yeah, there's one thing I should mention here, perception. it has been empirically established that if a program takes longer than 250 milliseconds to react to some kind of human action, the human thinks the program is slow, or not responsive, or not fast enough. What do you think we should learn from this?
So this 250 milliseconds, is it on the interface as well, or it's that on the back end?
Let's talk about the interface, because that's what I see as a
So, but
human.
do we see changes in interface in 250 milliseconds?
That's exactly, I mean, the response time, you're talking about the response time from every human interaction. There should be a response time that is lower than 250 milliseconds.
Yeah. So that's lesson number one. But there is something else which we should understand. Naturally, some things take time. For example, if you run a search query for your photographs in an archive of 50 gigs in size, you won't have a search result in less than 250 seconds. So what you should do when you can't give a result in 250 milliseconds, you should give a clear signal that says that I am thinking about it right now. And let's say you could give intermediate results, or you could show a progress bar, or you could show a prediction, something like estimated time to complete 5 minutes, or
He's locked out.
yeah. Can somebody please? You don't need this. You just.
I don't need
open
this.
it.
Oh, okay.